Hello, I am going to talk today about nomenclature, but showing you alkene, alkyne, and enynes. So that's another type of compound. Let's write it down. What is this then? An alkene, an alkyne with a triple bond, and this here have double and triple bonds. So these are enynes. So how we name those using IUPAC nomenclature. So always when we have one of these, we're going to be focusing on the functional group to choose our parent chain. So in this case, your functional group is the alkene, so you would choose the longest chain that contains that functional group. So that's the longest, 1, 2, 3, 4, 5, 6, and 7. If you go 1, 2, 3, 4, 5, 6, that will be shorter. So let's number that. So 1, 2, 3, 4, 5, 6, and 7. So that is a heptene. So hept being the prefix. Let's see if I can squeeze in the name somewhere. I might have to delete one of my little structures and draw it somewhere else to have room for my name. So give me a little bit of time. Okay, because I'll be using this space to actually write the name. Okay, so we said is hept, in them heptene. So the termination Enyne, and that is a 2, we can say 2-heptene or heptoene. Either way, it's fine. But then we need to say that we have substituents, we have metal, and metal. So it is a trimetal, and metals are in 5. So we say 5, 5, 6, 5, 5, 6, trimetal. Oh, not enough room. So let's do it. Let's squeeze it in. So 5, 5, 6, trimetal, and then I have 2-heptene or heptoene. And we also have some stereochemistry here. Notice that the double bond here is trans, so I need to add that to this. So the complete name will be that. So, but again, when you look at a structure like that, focus on what is your functional group, and then you choose your parent chain, the longest chain that contains that functional group. Then you will identify and name your substituents. In this case was metal, metal, metal. And remember that we need to number the chain so that you give the smallest number possible to your, in this case, priority functional group. So you need to number it this way. So priority to the double bond. Same idea here with alkynes though. And so your priority is your functional group, so the triple bond. So you would not choose to number that way. So your longest chain first, 1, 2, 3, 4, 5, 6, 7, but you renumber in this way. So let's do that. And let's do for that alkyne. 1, 2, that's a carbon, sp carbon, and that's 3, 4, 5, 6, and 7. This time is a heptyne. So hept again, heptyne. And so an alkyne, you can say 2-heptyne or heptoine. Either way works. Let me erase that name under there. So also heptoine. All right, then same strategy, select and identify and name your substituent. So metal, metal, metal. It is trimetal because we have 3 of those. So it's going to be 5, 5, 6. Same thing, similar, right? 5, 5, 6, trimetal. 2-heptyne in this case. All right. So now we have another class of compounds, which is the one that I have drawn below. And these, as you can see, have a double and a triple bond. So these belong to another family of compounds. These are enynes. And enynes, we're always going to name it enyne, but so keeping that structure in the name, but we need to say where is that in, so the alkene, and where is the yne, so the alkyne. So, and I have several examples here. In the structure that I have above, and I'm going to have to redraw that over again because I need to move over and keep writing my name. So, the structure that I have above. Notice that if I start, I have two functional groups. So in the name, we're always going to say enyne, but what takes priority depends on what is the first point of difference in the chain. So here you see that the alkyne is terminal and the alkene is not. So here you will have to number that starting in number 2. So because the alkyne is terminal, we're going to give this carbon a number 1. So we're going to say 1, 2, 3, 4, 5, 6. And now it's an enyne, but it's going to be 4 in, and 1 yne. Now I need a number 1 because, again, the triple bond is terminal. And I need a prefix, so hex, because it's 6. So hex, 4 in, 1 yne. That's a prefix. So again, you notice the first point of difference. The alkyne was terminal. This is not. So we're starting from that point. This is first. And the alkene was not terminal. So I'm using the name is always going to be an enyne, but I need to specify where is the triple bond and where is the double bond. Here's another example, this one here. I see, again, a double bond and a triple bond, but if I look at the structure, I see that the double bond is terminal and the triple bond is not. So the first point of difference is actually this and. So I'm going to number now this case like that. So 1, 2, 3, 4, 5, and 6. It's another heptime, but this time hexyne, sorry, it is 6 carbons. So prefix is hex again. But name is always enyne, but we need to say where the in is. So it's 1 in because you're double bond, and here's your carbon 1. 1 in, and then 4 yne. So again, focus the first point of difference. Because this case, the alkene was terminal, the alkyne was not. But what if we have a compound in which both the alkene and the alkyne are terminal? Well, in that case, the alkene takes priority. The name is always enyne, so let's number that. Chain alkene having priority, and that's just a rule from the IUPAC. So 1, 2, 3, 4, and 5. So this time the prefix is pent. So we're going to say pent on that. And then when you say where is the in, right? So the in is taking priority is 1 in and 4 yne. So that's how you break it. Again, always the name is enyne. We just need to say where is the in, so the double bond, and where is the yne, the triple bond. And look at the first point of difference here. First is the triple bond. If you start on this end, is terminal. And in the second molecule that we did, the double bond was first. And so we do the numbering that way. If it is the same, priority then is the alkene over the alkyne.